Hey guys, so here I'm gonna show you the second problem of the exam, right? Here the topic is about formal demonstration of limits using epsilon and delta, okay? So here we need to understand that this is a proof, okay? And because it is a proof, sometimes they're not gonna give you this value, okay? So you have to evaluate the limit using this x, and you're gonna have the result. But you have to prove it, okay? In this problem, I'm just gonna use I'm gonna show you how to solve it, right? But in case you wanna go deeply in the explanation, you can go to the channel of Professor Steve Cho, Black Pen, Red Pen. Fantastic videos they have where you can learn a lot about this type of limits, okay? So let's go. So because it is a proof, we need to write, right? This is a proof. And we're gonna use 4 keywords, right? The first one is given. The second one is suppose. The third one is check, right? And here I'm gonna write choose. Okay, I'm going to explain you each one of them. Okay, so how this works? Basically, if you have, let me say, okay, yeah, we're gonna have this one. Okay, wait a second. Yeah, perfect. Okay. So imagine that you have, I don't know, this function. Right. Imagine that function. So basically, and imagine that this function is going to be f of x, okay? So if I evaluate a number in this function, let's say we're gonna evaluate, I don't know, this number, I don't know, 4, okay? So here I'm gonna have a value, right? So imagine that this is 3, okay? So at the very end, the point is for 3, okay? Yeah. So this epsilon is gonna be here. The epsilon as itself, it's gonna be here. We're creating an interval, right? This interval where you're gonna have the result of the function, okay? And this is gonna be the epsilon, which is a radius. And of course, because it is an interval, it has to be greater than 0. That's why we say here greater than 0. Then we're gonna say here that the absolute value of x minus, in this case, is gonna be x sub 0, which this is the x sub 0, x minus 2. In the case that we're gonna have minus 2 here, then you have to replace it with positive 2, okay? So it's gonna be greater than 0, right? And less than this delta, okay? And knowing that, okay? So now that we have this, I'm gonna say the following. I'm gonna say that we need to check that x squared minus 3x plus 2 divided by 2x minus 4, right? And I don't say anything about that, okay? Of course, this has to be like an equal delta, but we are not gonna put it, okay? And I'm gonna show you then what we're going to do. And here we have to establish a relationship. Let me do this more here, okay? And here we have to establish a relationship, right, between the delta and epsilon. Something here, a coefficient that we don't know yet, okay? Now, let's do it. So what are we gonna do? From here, I want to go here, okay? That's the main goal of this problem, okay? So let's do it. I'm gonna write this again, okay? And sorry, I just made a mistake here. I apologize. So this is gonna be this expression, as you can see here, minus 1/2. So the goal is to go from here to here. I mean, to this expression, okay? To use this expression. Okay, perfect. So let's go. Here, as you can see, I'm gonna have this one, 2x minus 4 minus 1/2, okay? That's it. So if we want to multiply this fast, I'm gonna multiply here by 2 and 2. And here I'm going to multiply 2x minus 4. 2x minus 4. And then I just can add or do the rest, okay? So let's do it. I'm gonna have 2x squared, and sorry about this, okay? Remember, absolute value, okay? So let me do it better this way, okay? Just so you know, and this can be more clear, okay? Okay, perfect, yeah. That's excellent. So again, 2x squared minus 6x plus 4 minus 2x plus 4, okay? And divided by 2x minus 4, okay? Absolute value, perfect. So let's do it. 2x squared minus 8x, sorry, plus 8 divided by 2x minus 4, okay? Absolute value. As you can see here, I can factorize this expression, right? We're gonna have 2x squared minus 4x and plus 4, okay? So I can divide this, say this situation, or better this way, okay? And then I'm gonna say 2x minus 4, okay? Perfect. At the end I can do this, minus 4x plus 4 divided 2, and here I can do something interesting here. I can say 2, I can factorize this. Perfect. So I'm gonna do it that. At the end, the absolute value of 2 is 2, okay? So no problem. And here I can factorize it, right? What we're gonna have? We're gonna have x minus 2, right? Right? Because, yeah, basically, yeah, we have it here. Okay, perfect. And then I'm gonna have this one. And we're gonna have the 2 here, x minus 2. At the end, I can simplify this one, okay? So let's see. We're gonna have x minus 2 divided by 2, okay? So I am able to use this expression that we have over here. This expression, I can use it. So I can establish a comparison. We know that the delta is going to be greater than the absolute value of x minus 2. So I can replace it, okay? I'm going to replace that. So we're going to have x minus 2 delta over 2. Delta over 2. So, as I told you before, I want to establish a comparison between the delta and the epsilon. And I told you, like, okay guys, imagine that this is gonna be that delta is gonna be greater than this expression. I'm just gonna tell you. I tell you this so that you can understand where we are going, okay? But you can do it this way, okay? Just so you know, just so you be aware of it. So I want a relationship because at the end I know that this is gonna be what is gonna be. It's gonna be epsilon. So I need to find a relationship here. So maybe I can replace this delta with 2a. If I multiply 2a divided by 2, then we have the delta. So that's the relationship that we want. Okay, so you go here, let me erase this, and you say, okay, so delta is gonna be 2 epsilon. Okay? Perfect. So we have proved this limit. And that's it, guys. So that's how you can solve the problem of the formal demonstration of limits using epsilon and delta. Thank you, guys. Bye-bye.